This is Unit 9, Lesson 2. The learning target is I can solve quadratic equations by using graphs and square roots. The do now says to find the vertex of the following and use your graphing calculator. Right? Always use your graphing calculator. By the way, this is the formula to find the axis of symmetry, but we are concentrating right now on the vertex using your graphing calculator. So we are going to input y equals x squared minus 6x plus 8 into the calculator. So we'll bring in up the calculator and we are going to put that directly into our calculator. Yep, so please put that in, x squared minus 6x plus 8, and these are the keystrokes right down here that you would have to put that in. Now, obviously, we're going to see what the parabola looks like, so press graph. And we can see that the parabola is right there, perfectly situated on the coordinate grid. So since this parabola opens up, it has the vertex at the minimum. It has a minimum, and the minimum is somewhere right about here. All right, so on the calculator, there's an easy way that you could calculate where the minimum is. Press second function and then trace. Once you're at second function and trace, now you have the calculate screen, and we're going to focus on the minimum and the maximum. Since this is a parabola that opens up, you know I said that this has a minimum. So we're going to press 3. And you see where this X is right here? It says left bound. This X is right up here. We're going to just move that closer to where the vertex is. Right about there. It doesn't matter exactly where, so as long as it's a little bit closer. All right, we're going to press enter. And then it says right bound. You notice that it says right bound. We're going to move that X all the way over to the right by pressing the right directional button on the calculator. And once you have it over to the right, you press enter again. Then it says guess. And I guess that's my guess, which is right about there. And it doesn't matter, again, it doesn't matter where you put it. It's right about where I have the X. So press enter one last time and you get a minimum, which is the vertex, of 3, negative 1. And that is the vertex. You can go back to the lesson, 3, negative 1. And that is my vertex. Taking a look again, do you see right here the axis of symmetry would be right here at x equals 6. X equals 3. Right? So it would be right here. So figuring out that vertex, you remember in one of the slides that we had, we said that the x of the vertex is always that axis of symmetry. X equals 3 in this case, if they asked for it, which they don't. All right, let's take a look at number 2, and we're going to put number 2 in, x squared plus 2x. X squared plus 2x. We're going to go back to y equals, clear that out, put x squared, we're going to clear this, x squared plus 2x. I'm going to press graph. Take a look at that parabola. Again, it's opening up, so this has a minimum as well. So press second function and trace again for the calculate screen. So since this opens up, like I said, it has a minimum. As far as the vertex goes, the vertex is at the minimum. We are going to go left bound, and left bound is to the left of where the vertex is. So exactly where I have my X, that's exactly where I moved it by using the left button on the calculator. Now you can press enter and it says right bound. Please move that X to the right of where you think the vertex is. And you press enter one more time. Now it's asking you to guess, and I'm going to say it's right about there. And I'm going to press enter for a third time. And I have my minimum as -1, -1. If you didn't get that exactly, then you got something with like decimals very, very close to where the negative, where I have what I have. Just round it to the nearest whole. In this case, which would be -1, -1. So now we go back to the lesson, and we are going to put -1, -1. And that is my vertex. All right, state test prep. Which graph of the y equals x squared minus 1 shifted 5 units up? We're going to press pause. We're going to just graph this original one on the calculator, and then graph these and just pick the one that is 5 units up. Go ahead, press pause now. So make sure you have your calculator again. And we are going to press y equals and clear out that last question and input x squared minus 1 and press graph. So in this question, it's asking you to see exactly which one of these choices shifts this up 5 units. And we are going to just start graphing. So we have y equals, again, we're going to press y equals, we're going to put x squared plus 4, which looks like it might, since this is a -1 and this is a plus 4, that really does look like it might work. Let's see. Okay, so just take a look. This one right here is at -1, and this one is 4. That is 5 units up. And you could go ahead and circle A just by the look of it. Now you could also get the vertex of each one and go through and just make sure. Remember, getting the vertex is easy. If we wanted the vertex of the blue original parabola, exactly where it is right here, you see, actually it's right here. It's x equals 0 and y equals -1. You could go left bound. It's like one of those easy parabolas. It went right to it, and then guess. My guess is right there, and the minimum is 0, -1. All right, and then you could do the next one and do it the same way, and you would get 0, 4, and that makes sense right there. Perfect, pretty easy. Shifted 5 units up. First one I tried, and that's basically it. Work with a partner. I guess we can't do that anymore, right? So solve each equation by graphing. So we're going to just go ahead and start graphing these with the graphing calculator. And this is x squared minus 4 equals 0. And we are going to graph them, and using that graphing calculator, just go ahead, clear out what we had here in y equals. We're going to clear that out and clear the second one out, and then just input what you have there as a question. It's x squared minus 4. So that's what I'm going to put in. X squared minus 4. And graph. To get those the actual coordinates, press second function and table, and you will have your coordinates. Just go to where it says like maybe -4, -3, right? Because you really can't fit anything else on there. It's -3, -3, 5, and just put a point right there. And then -2, 0, put a point right there. And -1, -3, you'd put a point right there. And 0, -4, right there. 1, -3, put a point there. And 2, 0. And the last one is 3, 5 that you could fit. Go ahead, draw your parabola connecting those points, and you could see you should probably name that vertex. We're going to name the vertex for each one, and that's it. So press pause to A and B now. Press pause now. So for A, when you plot your parabola, they have something called the zeros. And the zeros, known as where x, where the parabola crosses the x-axis. All right, they're called the zeros. This is -2, 0. This is 2, 0. So they're called the zeros. So when you're solving each equation by graphing, you're graphing that parabola, and then you're circling right here and right here, and you're identifying those as the zeros. So we are going to say that this is x equals -2 for the left side. And we're going to put a comma, and we're going to put 2 for the right side. And exactly where they're circled, and I have that red dot, that's where the parabola crosses that x-axis, and those are called the zeros, and that's actually solving for that equation by graphing. All right, go ahead, do B, try to get those zeros. By the way, even if you had the vertex, what is the vertex of this one? If they asked you, they're not asking you. But the vertex is at a minimum, and the vertex is 0, -4. Zero, -4 for the vertex. But solving them, exactly what I just put right there. Just remember, you have to see exactly where that parabola crosses the x-axis, and that's known as the zeros. Alright, so I just wanted to show you using the calculator here that you could get the zeros on the calculator if they're not like this, pretty perfect. You press second function calc, going back to that second function trace, and you're on the calculate page. You see this number 2 right above the minimum and max is number 2, and it says 0. Left bound of where it crosses the x-axis for the first time on the left side first is enter, and you press enter, and then you could go to the right side of that and press enter, and then guess you can move it right about here and press enter, and that's your 0. Obviously you could tell exactly that the x equals -2. Let me just go over that one more time on the other side now. Pressing second function trace and you're pressing that number 2 for 0. Going to the left bound on this side is below where it crosses the x-axis. You press enter. Right bound on this side is above. Then press enter, and then you could guess right about there, and the 0 is 2, 0. Just in case you wanted to use your calculator, you should be able to use your calculator for it, just in case it's something like in the middle of 1 and 2 and you don't really know if there's a decimal. That's how you would do it. It's the same second function and trace, right? That's the min, the max, the 0. There's a lot on this page here. A lot of functions. Go ahead and do B, and we'll come back with the answers. Press pause now. Okay, graphing this one, x squared plus 3x equals 0. You get this parabola, and you get that the x equals, and this is -3 on the left side and 0 on the right side. All right, and those are the zeros. You solved. Vertex is somewhere down here, and that's basically it. Try C. We'll press pause and get the solve for the zeros. And press pause now. Okay, so we have the zeros solving for this. X as 0, which is the left bound, the one on the left where it crosses that x-axis, and on the right it is 2. So solving would be perfect like that. This is really the first question that we had a parabola facing down. So I just wanted to kind of just go over how you get the vertex, and we could do zeros as well. You could press second and trace, and since this is a facing down, this is a parabola that's facing down, it has a maximum, so that's where you would go maximum. So you press 4. Left bound, that's pretty much set up left, so you press enter. Right bound, you would go right about here and enter, and then you would guess, you'd put it right about there and you'd enter, and you'd say that that is 1, 1. All right. For the zeros, which we just did, you press second function, calculate again, go to 0 this time, which is 2. Left bound is right about there. The first time it crosses the x-axis, left of that is left bound. So you press enter. Now go to the right of that and press enter again, and then you could guess at right about there, and it is 0, 0. If you wanted to do that one more time to get the other side, you'd press second function and trace again, go to 0, the 2 again, which is your zeros. This is left of the second time it crosses the x-axis, and then right bound would be below the x-axis, and guess would mean that it would go directly on the x-axis, and it is 2, 0. So basically that's how you would do that on your calculator. Just wanted to show you that. Go ahead and see if you could do D. Pause the video now. So hopefully you had that parabola right there, and it only touches once. You realize it only touches that x-axis once. So it only has that 1, 0. So we have x equals 1. And that's it. All right. This parabola, you could tell, crosses the x-axis twice. This one only touches the x-axis once, so that is the answer. And just remember, always put the label your parabola. Make sure you're labeling the parabola every single time. And once you label your parabola, you're finished. You have identified the 0, x equals 1, and that's basically it. All right, what I wanted to show you is what the fast finisher was asking. How do you solve these algebraically? It's important to know how to solve these algebraically also, and graphically, because you're going to use your calculator a lot in 9th grade. But if they asked you to solve it algebraically, you would have to factor x squared minus 4. This is the difference of squares, and I just wanted to show you exactly what is happening here. So when you set this up, you're going to set it up x and x, and you're going to put equals 0, right? So what times what equals 4, or negative 4, I should say. What times what equals a negative 4? Well, it's plus 2 and minus 2. So you're set up just like this. Remember we said what the zeros were. The zeros in this case were negative 2, comma 2. And this is what happens when you have that equals 0. This is the next step. You split this up into two equations. If x plus 2 times x minus 2 equals 0, that means one of these has to be 0. So when you set it up, it's x plus 2 I don't know why I'm writing this, but equals 0, and x minus 2 equals 0. One of them has to be 0. So you just solve this for x. Minus 2, minus 2, plus 2, and plus 2. Then you have x equals negative 2, and x equals positive 2. Exactly what we did get for the zeros in this one. X equals negative 2, there it is, and x equals positive 2. So this is algebraically, this is graphically. It's important to know. We'll go over it a little bit more, obviously, but that's how you would get that answer if you didn't have a graphing calculator, and also if they asked you to solve for the zeros algebraically. That's exactly how you do it on the right hand side. One more with you, and it's D, and I'll show you how this x equals 1. The 0 is only 1 0 here. All right, it's only one time that it touches or crosses the x-axis. So go ahead, and we're going to say, all right, I have to factor this trinomial, and then it's equals 0. So what times what equals positive 1 and adds to a negative 2? Obviously that's 1 and 1. And it has to add to a negative 2, so both of them are negative. And you could check that out. You could really just check that out by going negative times negative 1 times negative 1 is a positive 1, and negative 1 plus a negative 1 is a negative 2, or negative 1 minus 1 is negative 2. So that's how you would get that right there. So now you would just go, all right, since they're the same thing, you really only have to put it down once. But if you wanted to put it down twice, I mean, really, you could. But you would have to realize that you are going to come up with the same answer. right? So you would add 1 to both sides. Adding 1 to both sides would make this x equals 1 for both. Since they're the same thing, I wouldn't even write down the second one, but it is x equals 1. And look how it matches what we have graphically. There, right there. Yeah, right there, I said. Yeah. So that's basically it. And I just wanted to go over a couple with you algebraically before we move on with the lesson. Okay, so this is something that is just really good to have in our lesson. Just one page where it just shows you exactly what's going on. Remember, the standard form of quadratic equation is ax squared plus bx plus c. All right, that is the standard form. The number before the x squared is always a, the number before the x is b, and the last number is c, where a does not ever equal 0 or cannot equal 0. One of the ways to solve a quadratic equation is to find the roots of the equation or the zeros. The roots and the zeros are the same thing. They're called the same thing. They're the roots. It's where the parabola crosses the x-axis or touches that x-axis. So if they ask you to solve for the roots, they're asking you to solve for the zeros. And the reason why they call it the zeros is because where x is a number and then y is always 0 at that point. It's always crossing that x-axis. So it's very easy to solve quadratics by graphing. You just put them into the graphing calculator. They might have 2 solutions, like in that first one that you see on the left side, this one. This has 2 solutions. It crosses the x-axis twice. And this one says x equals plus 2. It's a positive 2 and a negative 2. You could write it this way. And x equals 0 for one solution, or it could have no solution. We didn't even try a no solution one, but if it doesn't cross the x-axis, guess what? It has no solutions. All right. When it has no solution, that means that you can't solve it algebraically either. All right. You're not going to be able to solve c, x squared plus 4 equals 0. There's no way to factor that. All right. So that's basically it. So for the zeros, it has no solutions. It never crosses that x-axis. And that is basically it. So the next page is just basically giving you a step-by-step of what to do on the calculator, which we did already. And I showed you about the calculator, and we'll continue to do that and make sure that you're okay. I'll also put another video up of me doing some random problems on the calculator, and just to have a little bit of a shorter video of just showing how to use the calculator and everything like that, and you could watch that. Hopefully you can get that. Remember, you click the second function and then you hit trace, and that will bring you to the calculate page, and then you hit the 2 for the 0. You're hitting 2 for 0 because, again, you're solving for those zeros, and the calculator will remember, go left bound, press enter, move the cursor to the right, press enter, and then you guess, and press enter one more time, and it'll give you your answer. And that is basically it. Okay, I'll do the first one with you on this page, and we're going to bring up that calculator because that is definitely something that we need here. We're going to clear that out, and we're going to go to y equals, and we're also clearing that out. Go ahead and put x squared minus 1, and this is all graphing by using the graphing calculator. This is not algebraically, all graphing. So we're going to try to figure out the zeros of the function, or the roots of the equation of the parabola are. So here is the parabola. We're taking a look at it. It looks like it crosses at -1, 1. Right? Just to make sure, though, we're not going to put that down. So we're going to put down this 1 as x. The answer, we'll put the answers down here. And we're going to see if that is correct. Press second function and trace. So we are going to go to 2 right now, and we are going to see if left bound, we're going to move that left bound to where it crosses, before it crosses the x-axis the first time, and right bound right after. I'm just going to move my guess right there, and it is -1. X equals -1. And now I'm going to do it one more time. Second function, trace, and then press 2 one more time. And I'm going to go left bound, and there it is right there. And then right bound, right there. And then guess. I'm going to move it back to the right about there. And it is 1. X equals 1. And that's it. All right. Those are your zeros or roots. You could actually write them x equals positive -1. All right. Go ahead and do at least numbers 2 and 3, and we'll come back with the answers and talk about them. Press pause. Do those 2 now. Pause. Just taking a look at number 2, that's what you should have, and it is no solution. It does not cross the x-axis. Please do number 3. Press pause now. So number 3 looks like this, and you should be able to tell that 1, 2, 3, 4, that x equals -4. And x equals +4. All right, and that's basically it right there. You could write it this way: x equals positive and -4. That would show that it's both positives and -4 for number 3. Go ahead and do number 4. Press pause now. Okay, so number 3 is x equals -4 or x equals 4. Those are the roots. You could write it this way, or whatever. Try number 4. Press pause now. So I forgot to tell you about number 4. The thing about number 4 is that it's not set equal to 0, and it must be set equal to 0. So what you have to do is you have to take this 6 and you have to somehow get it over past the equal sign to the left side. All right. So how would you get a +6 over to the other side, to the left side? Well, yeah. If it's a +6, you do the opposites, inverse operations. You subtract 6 on both sides. Once you have that, you have x squared minus x minus 6, and that equals 0. So like we have over here for this one, don't forget you need to set the equation equal to 0 before you can graph it. Now you could go ahead and graph that, and you have x squared minus x minus 6, and you press graph. And there it is. So now you could tell really here that this is -2 and this is a +3. So x equals -2 or x equals 3. Right, so we're going to just check that out. Press second function, trace, and it'll take you to the calculate page. Presses the 2 for 0, and we're going to go left bound and just make sure that this is a -2, and then we'll go right bound and then press enter. And then for the guess, we're just going to put it right about there. And it's -2. You're right. Yeah, that was right. You'll do it one more time for the other side, going to the 0 function on the calculator, and that is the left bound. You press enter. Then you go right and you press enter. And then the guess you really don't have to really move it for the guess, but I like to, and that's x equals 3. So those are the roots of that parabola. All right, so go ahead, that quadratic, and do number 5. Graph it, see if you can find the roots. Press pause now. So I did put this into the calculator. Hopefully you did get something like this. Let's just double check that that is 2. It looks like x equals 2 as the root, as the single root. But let's go ahead and press second function, trace, and then go to the 0 function. So I'm going to bring this all the way over, left bound right about there. And then I'm going to bring right down here. And my guess will be somewhere around there. And it is 2, comma 0. So the root is x, single root, x equals 2. And that's it. Go ahead, try this last one again. Number 6, not again, but number 6. Try that and see if you can move this -9. Remember, do not forget, you need to set the equation equal to 0 before you can graph it. So this -9 needs to move over to that left side and then rewrite it. Then you could graph it and see exactly what it looks like. Press pause and try this problem now. So here we go. I'm going to clear this out. I added 9 to both sides, you could tell, as you can tell. And I did get half x squared plus 14 equals 0, because 9 plus 5 is 14. Right, so I'm going to graph that as, I could put 0.5x, or I could just press alpha x and bring up that nice handy fractions symbol there, and then half x squared plus 14, and that is it. Right, now we could press graph and just take a look at what we have. I don't see anything. All right, so remember what I said though about the half x squared plus 14. Remember the plus 14, I think of it as like, you know, in y equals mx plus b, it's like the y-intercept. Well, that 14 means that it's way off this screen, all the way up here, right? So the parabola is probably all the way up here. But to answer this question, do you really need to see the parabola? You're looking for the roots. Are there any roots here? No, there is no solution for this, or no solutions. All right, so there's no solutions because it doesn't cross the x-axis. You could see that it doesn't cross the x-axis, but just take a look. Let's just mess with the window, because I know that this is all the way up here. So let's just take a look at the window, and what do we need to increase here? The x has nothing to do with it, right? But let's go down to the y max, and I am going to put y max of 30. And let's see how that works out. There it is. All right, so I mean, if you really wanted to see where the obviously you're not going to press the zeros, and this has nothing to do with the question. If you wanted to see what the vertex is, this has a minimum because it is facing up, and that is the vertex right there. You really don't have to do any left bound, right bound nonsense, because it's right there, right off the bat. 0, 14. So it's 14 up from the x-axis. Never comes close to the x-axis, so no solutions on that one. All right, solving quadratic equations using square roots. This method cannot always be applied. You must use algebra to put it into the form of x squared equals c, where c is a constant. You have to find the square root of both sides, right? So you can't use this all the time. For this question, let's just go over what we have here. 2x squared minus 98 equals 0. Now, you have to try to solve for x. Remember, you're solving for x because you're solving for the roots. You're solving for the zeros. So you have 2x squared minus 98 equals 0. You add 98 to both sides because you have to get the x alone, try to get that x alone. Then you divide by 2. If you're dividing by 2, which is right about here, you know that these 2's, they cancel. Then you have x squared equals 49. So the x squared, the opposite of x squared is square root. So that's exactly why you have that square root there, because you're using, to get the x squared, to undo the x squared, you have to square root both sides. And when you square root both sides, there could be two answers. There's a positive 7 times a positive 7 that equals 49. And there's also a negative 7 times a negative 7 that equals 49. We don't talk about it much, but remember there's two answers to every square root. So if there's square root of 36, it could be 6 times 6, or it could be negative 6 times negative 6. So this one right here, it has x equals positive or negative square root of 49, and it's positive or negative 7. Two solutions, two roots. All right, so we have all of these problems here that we have to practice solve by using square roots. We're going to do that together one by one, and we'll just work it out. Not using the calculator here. Maybe we could use the calculator to actually to check to see if our answer is correct, but we're not going to use the calculator. We're just going to use algebraically to solve for the missing variable. Okay, so we are going to go ahead and solve some of these. The best way to do this is to actually just put it on a nice, just write these questions down on loose leaf or on the bottom of your page. Remember, there's some work that you're going to be doing here. So we are going to do all of these algebraically. So remember, has to be equal to 0. So t times t equals t squared. And we have a negative 25, so this is the difference of squares. And the difference of squares, what's the square root of 25? What times what equals negative 25? Yes, you're correct, 5. So it's plus 5, and then it is negative 5. So just like that. Now you could just go ahead and split up those equations. Just like this. Make them both equal to 0. I used to like to, I don't know, draw a line in the middle. You don't have to, but kind of like that. I mean, use inverse operations to solve for both. And plus 5. This one is negative 5. So t equals a positive and negative 5. And those are the roots. If you did bring up the calculator to graph it, you would see that t plus 5, actually I'm just going to graph the original, t squared, which is x squared, minus 25. And if you graphed it, I just want to get it back. Okay. If you graphed it, this is negative 5. And this is positive 5. And that's it. Just checking it out. Number 2, just taking a look at number 2, just remember this 12 has to go over to here. Right? So how would you get that 12 over here before you start graphing it? Before you start solving algebraically, you would just move it this way. So this would cancel, and so would this. So we have 3n squared equals 0. All right. So how do we solve for n? We divide by 3. Divide by 3. This cancels. The n squared would come down. And the n squared, 0 divided by 3, you could check in your calculator, is 0. So what do you do on both sides? You square root both sides to undo the square, and n equals 0. So that's the root. Go ahead, try number 3. We're going to press pause now. So for number 3, just taking a look at it, it is 2g squared plus 32 equals 0. So you subtract 32 on both sides, everything is going well, and then all of a sudden you have 2g squared equals negative 32. You divide by 2 on both sides, and you get g squared equals negative 16. Now the next step would be to square root both sides. But this is a problem. You cannot take the square root of a negative 16. If you try to take the square root of a negative 16, I'm going to clear this right out right now. You have second function square root and then negative 16, right? The calculator is going to say error, non-real answers. And so that means there's no number that multiplied by itself could equal a negative number. So 4 times 4 is 16, negative 4 times negative 4 is positive 16. There is no square root of a negative number. So please write that down. No square root of a negative number. Just remember that, and I'm sure you knew that already, but if you needed to be reminded, there is no square root of a negative number. So what is the solution then? All right, there is no solution. Now think about it. If this is 2g squared plus 32, this parabola is crossing at that y-axis at 0, 32, all the way up on that y-axis. If we took the graphing calculator and if we went to go ahead and graph that, it is 2x squared plus 32. Take a look what we have. We should see nothing. The reason why we're seeing nothing is because the parabola is all the way up here. It's crossing at 0, 32. So I am going to mess with that window just to prove that to you, that y max. I'm going to just put that as 60 in graph, and we could see that right there. That is 0, 32. All right, so just be aware you cannot take the square root of a negative number. So when you have the square root of when you have that and you solve it, square root of a negative number, you know that it is incorrect and has no solution at all. All right, try number 4 and number 5, and we'll come back with those answers and we'll go over them. Press pause now. Okay, number 4 is k equals 7. K equals -7. You square root both sides. The square root of positive and negative 49, and you get both answers. K equals 7. K equals -7. This one right here, you add 225 to both sides, and you go ahead and square root both sides because you have m squared equals 225. When you square root both sides, remember you have to take the positive and the negative answers. So you have m equals 15 and m equals -15. So you could put it down just like this. Number 6. So number 6 represents a little bit of a problem here. All right, so we have 27 minus y squared equals 0. So we might have a little bit of trouble bringing over the 27. See what you could do. Press pause and try this problem now. So the way I would do this, I wouldn't even try to move this 27 over. When I was saying before, I would just move this y squared over. It just makes things easier because then the y squared is by itself on that right hand side of the equal sign. So it makes it easier, and also it creates a positive y squared. So you have 27 equals y squared. Now you're ready to go and square root both sides. Once you square root both sides, remember it becomes y equals, and instead of taking that square root of 27 is not a perfect square, so I'm just going to leave it square root of 27. All right. If you did have to figure out the square root of 27, it would be a number like that. All right, either you would round it to a positive 5.2 maybe, and then a negative 5.2, but I would just leave it right there, and it's just much easier right here, like that, with the square root of 27. Okay, so go ahead and try 7, 8, and 9 on your own, and we'll come back with those answers, see if we can do, and press pause now. Okay, so number 7 has no solution. You subtract the 12 on both sides, and you can't take the square root of a negative number, so no solution. Number 8, you add 5 on both sides. You have 0 there, which is negative 4x squared equals 0. You divide by negative 4. You square root both sides. The square root of 0 is 0. All right, 2x squared minus 98 equals 0. You add 98 on both sides. You divide by 2. And then you get x squared equals 49. You square root both sides. You get x equals positive 7, x equals negative 7, and that's basically it. So to go on to the next page, Hopefully you got those. Determine the solutions of the equation. You could just take a look at what number 1 is. Very, very easy. You could put x equals, and the solutions are the zeros, the roots right here and right here. So very, very easy. X equals 4, and you could put comma, x equals 6. Go ahead and do numbers 2 and 3 equals 6. As I'm saying 3, I'm putting 3. That's a 6. All right, and then we'll come back. So press pause and try those now. All right, so number 1 is, we did it already, 4 and 6. Number 2 is just x equals -6. It only hits that x-axis once. And number 3 is no solutions at all because it does not come close to that x-axis, or touching it, it doesn't touch it, and it doesn't go through. So number 4 and number 5, please use your calculator to figure out what the roots are, the zeros. Determine the solutions of those equations. Press pause and try those questions now. Yep, so x squared minus 2x plus 5 is that right there, that quadratic. I put that into the calculator and it does not touch that x-axis at all, so this is no solution. No solutions. And the next one right here, we will go ahead and graph. We'll do that right. Hopefully you did that already, but it's -x squared plus 14x minus 49. And we could press graph right there. Wow. Error. So I got an error and I was like a little bit confused. So I had -x squared. I have to you have to double check. See this? I put 2 addition signs there. So I'm just going to clear that out again. And sometimes that'll happen, and you know, just check to see what you put in into the calculator, because sometimes you do press something twice. And let's go ahead and graph it now, and there it is. All right, so we have right here the 1, 2, 3, 4, 5, 6, 7. So x equals 7. Only touches it once, so x equals 7. And that is the solution. All right, so rewrite the equation in standard form. Remember, the standard form is x squared, ax squared plus bx plus c, right? So that's standard form. Right now, this is not in standard form. So what we have to do is we have to get these over there, all right? You could get this over here, but either way, you have to make it equal to 0. And since these are the negatives, I want everything as positive. So I'm going to add x on both sides, and I'm going to add 3 on both sides. And I'm going to add x, and I'm going to add 3. And at the end here, I'm going to get standard form, rewrite the equations, then solve the equation by graphing. It is this, x squared plus x plus 3, and equals 0. So that is standard form. We are ready to go with this calculator here, and we are going to graph that by putting it into the calculator. X squared plus x plus 3, graph. All right, there we go. There is no solution. And that's basically it. No solutions at all. Now we can try the next one. Go ahead. You could try it on your own. We'll press pause. Just go ahead, put this in standard form, graph it, see what the solutions are. Press pause now. And there you have it. I would subtract the 6x on both sides, add the 8 on both sides. You get x squared minus 6x plus 8 equals 0. You graph that in the calculator. You get the parabola that is shown right on your screen. On my calculator, x equals 2 and x equals 4 are the roots. Alright, so here's a real world situation here that you have. We are going to look at this question. A baseball player throws a baseball with an upward velocity of 24 feet per second. That's what this is. And the release point is 6 feet above the ground. That's what that is. The function h equals negative 16 t squared plus 24t plus 6 gives the height in feet of the baseball after t seconds. Right? So we're just going to graph it. So use that graphing calculator. Putting negative 16 x squared in plus 24t, 24x plus 6. And we're graphing that. So just take a look. So that is your parabola. And it's asking how long is the baseball in the air if nobody catches it. So first off, the roots are h equals 0 and h equals about 2. Nobody catches it. How long is the ball in the air if nobody catches it? So what you do is you just put this directly in that real world situation right here. Put it directly into your calculator, right? So they give you the equation. And then you just have to find the zeros. So the way you find the zeros, press 2 and you're going to say, alright, left bound. And you press enter once. Then you say right bound. And you press enter once. You press enter again for the guess. And you see this x, which is 1.71. You round that off to 1.72. Alright. 1.72 is the time if nobody catches it. 1.72 seconds. Alright. And that is it. Okay. So here we have an exit slip, and just take a second and do this. I'm not even going to pause the page. What are the roots of this equation? Alright, so go ahead, put a point there, and put a point here. It's not negative 4 only, it's actually not even negative 4. Gone, gone. Right, this is negative 1. Right, so negative 1 is part of your answer, and this is positive 4. So 3 is your answer. Hopefully you were able to see that, and you were able to do that with me very quickly. Go ahead, this one we will press pause. Go ahead, see if you could do number 2. Is 4x squared minus 100 equals 0. Figure out the roots algebraically, or using your calculator. It's up to you. It doesn't say. We'll do both when we come back. Press pause now and try this problem. Okay, so here we go with number 3 as the answer. It's -5 and +5. We have 4x squared minus 100 equals 0. Over here you can tell what I did. I added 100 on both sides. Then I had 4x squared equals 100 dividing by 4. Solving for x, you get x squared equals equals 25. You square root both sides and you get x equals +5 and x equals -5. If you did put that into the calculator, if you didn't solve it algebraically, it would be something like this: 4x squared minus 100. And you press graph, and you see that right there. And again, you don't need to see the vertex, but this is 5, this right here is -5, and this is +5. So you are correct with that. No need to mess with it at all. All right, and that's basically it for that question. Just before we go, I just wanted to take a look at the first page right here, and we were supposed to use this formula to figure out the axis of symmetry. But the axis of symmetry, if you find the vertex using the calculator, you really don't need to use this formula at all, because the axis of symmetry, remember, goes through the center of that part where the parabola is, right? So it always is this x value, right? So, but I did want to go over one with you, and when you have to use that formula, if you ever do, this -b, if this b is already negative, this b is -6, this a is 1, and this is c, right? So we have -b, which is negative 6 with a negative on the outside. And 2 negatives make a positive. And so I'm just going to put a +6 up there because it's -6. So that's 6 over 2 times a, which is 2 times 1. And that's 3. 6 over 3 is, sorry, wait a minute. I'm losing my mind a little bit. It is 6 over 2. 6 over 2 is 3. And you see x equals 3, and that vertex, I mean, is that x is 3. The value is 3. So if you did this one the same way, using the formula, this is b is a +2, and they want negative, right? A negative b. So it's -2 in that case. Then it's 1, this is a, so that's 1, so it's 2. 2 times 1 is 2. -2 divided by 2 is -1. So it's kind of like, do you need the formula? Not really. All right, only if they really ask you to use it, but I don't think so. You could get the axis, you could find the axis of symmetry anytime by just finding the vertex and just using the vertex's x value as the axis of symmetry, because that's what it is. And that's it. And I hope you found this video useful. And that was Unit 9, Lesson 2. Bye-bye, everybody.